This is the solution to quiz number 2. The question was, the human cannonball is launched at 40 degrees with a speed of 20 meters per second. If the net they land on is 2 meters higher than the launch point, how far away should it be? All right. So let's sketch, right? First step, here's our cannon. Human cannonball in here, ready to be launched. And our net somewhere over here. Higher than his initial position. All right, so our given information is that the net is 2 meters higher than his launch position. So one thing I want to point out is that that means there is a solution here and here for y, right? So that means that we're going to have 2 times that work in our equation, and we're going to choose the later. A lot of the problems we've done have either had a negative time for one of them, or it was clear which one to choose. This time, we want him to land in the net, not hit the net on his way up, right? So we're going to choose the second time. All right, so there's our sketch. What does that tell us? That tells us that our delta y is 2 meters. We want to know where to put the net. That's our delta x. That's what we're looking for, right? We don't know t yet. We know our initial velocity, though, was 20 meters per second at 40 degrees. So we need to use some trig and figure out the x and y components. So our v naught y will be 20 sine 40, and our v naught x will be 20 cosine 40. Just grab my calculator and plug those in. 20 sine 40 degrees gives us 12.86 meters per second. 20 cosine 40 degrees is 15.32 meters per second. All right. I just like to organize my data this way. We now have our delta x is what we're looking for. Our delta y is a positive 2 meters. AX is 0. AY is minus 9.8 meters per second squared. And again, I've assumed a standard coordinate system. I didn't actually draw one in here. Let's be explicit about that. All right. And what else do we know? We know our V naught, right? V naught X is 15.32, and V naught Y was 12.86. All right, and that looks like all of our information. This is another case where we know more information about Y, so we're going to use that to find time. So delta Y is V naught Y times T plus 1/2 AY T squared. So bring delta Y to the other side and we'll get minus 2 meters plus 12.86 meters per second times T minus 4.9 meters per second squared times T squared. All right, so using our quadratic formula, our quadratic term, that's our AX squared, BX, and C, right, in our quadratic formula. And we get T is equal to 12.8 minus 12.86 plus or minus the square root of 12.86 squared minus 4AC all over 2A. Grading the quizzes, I saw a few people get their trig backwards. I saw sign errors here. And I saw people plug in the C instead of A in the denominator. So those were common math errors I saw. All right, when we work this out, we get, let's see, 12.86 squared minus 4 times 4.9 times 2. And the square root of that gives us 11.23. So what does this equal? If we take the plus, then we'll take 12.86 negative, right? Plus 11.23 gives us minus 1.6. So divided by negative 9.8 gives us 0.17 seconds. Okay, and as I said at the beginning, we're going to choose the second time. So let's see what happens when we plug in the negative. So 12.86 negative minus 11.23 gives us 24.09 divided by negative 9.8 gives us 2.46 seconds. So that's the time we choose for this one. Now we have the time, we can use that with our x equation. Delta x is V naught x times t plus 1/2 AX t squared. AX is 0. Delta x is what we're looking for, and we just found time. V naught x was 15.32. So 15.32 times the time that we just found, 2.46. Right, this is meters per second times seconds, which will give us meters. 15.32 times 2.46 gives us 37.7. And for the significant digits we had, we could round that to 38. All right, so there's the solution to the quiz that we took on projectile motion.